It seems as if we know Jupiter like the palm of our hand. A huge gas giant, the second largest body in the solar system after the Sun, the planet with the most satellites and the savior of Earth from asteroids. Did you miss anything? At first glance, no. And here's a surprise, it was recently discovered that Jupiter is actually not what it seems. But what do we really know about this gas planet? What is its internal structure, the composition of its atmosphere, the peculiarities of its magnetic field? We'll dispel old myths and learn fresh facts about Jupiter's structure, atmosphere, and mysterious satellites. How in the world could Jupiter get so huge and still be in balance with the other smaller planets and the Sun? Even Saturn, the second largest gas giant, is almost 3 times smaller than it. Jupiter started out somewhere on the outskirts of the solar system. And when it was young, it was the furthest away from the planets, so it gathered dust and gas. So it was skewed by the constant collisions with debris. The planet slowed down. And since, according to Einstein's theory of relativity, gravity is the warping of spacetime by mass, the implication is that gravity is not a force in the traditional sense, but rather a manifestation of the geometry of spacetime. And we all just fall into the Sun, then, losing speed to counteract the fall. However, its gravity is too great for it to get close enough to the Sun to be absorbed by it. That's how the solar system got the delicate balance it's in to this day. It was only in 2022 that the dark details of Jupiter's formation and movement were revealed. The theory that its entire core is a collection of pebbles and dust after receiving new data from the Juno probe gave a crack. For the data showed that the material inside Jupiter is unevenly distributed and has several areas with different densities. Although it would seem that it should be an evenly gravitationally stirred mush, reality showed the opposite. Jupiter could have formed not from small particles and dust, but from larger objects such as planetesimals. In addition to the gravitational anomalies revealed that only heavy, or as scientists say, metallic elements on Jupiter gained as much as 22 Earth masses. It's hard to imagine, but the conditions inside Jupiter are hellish. Temperatures as high as 20,000 degrees Celsius, 36,032 degrees Fahrenheit. And the pressure is millions of atmospheres. At these temperatures, ordinary substances behave in unusual ways. For example, hydrogen becomes an electrically conductive metal. Like any other planet, it may have originally been rocky, like Earth or Mars. It may have become a gas giant when gravity became so powerful that it began to suck in gaseous matter in addition to dust. But here's the catch. This is far from the only reason for the uneven distribution of material inside Jupiter. First, Jupiter may have formed from several large objects that collided with each other. Second, it may have originally had a homogeneous core, which was then split into several regions due to gravitational interactions with other objects. Third, Jupiter could have a liquid core in which material is moving and stirring. Which seems more plausible to you? By the way, if it has an inner core at all, it's probably the size of the Earth, about 12,742 kilometers or 7,918 miles in diameter. Above that is a thick layer of liquid metallic hydrogen mantle. Finally, on the outside, there is a thin gas atmosphere. Jupiter's atmosphere is a separate universe with its own continents, seasons, storms, and elements. Jupiter's atmosphere is made up of hydrogen and helium, but there are also traces of methane, ammonia, water. It's these small additives that give Jupiter its characteristic color. It consists of several layers. In the lower troposphere, clouds of ammonia and ammonium hydrosulfide form. Above that is the stratosphere with turbulent air currents. It's an interesting set, isn't it? But it's Jupiter's mysterious atmospheric phenomena that draw us in the most. Who hasn't heard of the legendary Great Red Spot? This superstorm has been raging in the atmosphere for at least 350 years. It's about twice the size of Earth. You can even see it through an amateur telescope. In addition to giant vortices, whirlpools, bright streaks and jets of ionized gas cross Jupiter's atmosphere. They move at tremendous speeds, creating a unique dynamic pattern of clouds. And in the uppermost layers, real electrical storms rage, accompanied by powerful lightning discharges. Some of them reach 1,000 kilometers, about 621 miles, in height. Jupiter is surrounded by one of the strongest magnetic fields in the solar system. It's 20,000 times more powerful than Earth's. How does the magnetosphere interact with solar wind streams? Like Earth, Jupiter has a shockwave about 50 radii away from the planet. Behind it is a magnetospheric tail stretching millions of kilometers. Inside are the radiation belts, areas with high concentrations of charged particles. We should not forget that Jupiter rotates about every 10 hours. This is the so-called Jupiterian day. But it takes about 12 Earth years to complete one revolution around the Sun. The next interesting thing is the weather. The Earth is tilted about 23 degrees. That's why we distinguish between fall, winter, summer, and spring. Jupiter, for example, has no tilt. Its axis is tilted only 3 degrees, and all parts of the planet receive plus or minus the same amount of heat. And there's no change of seasons. But what if there is a weather shift on Jupiter after all? Since 1978, the VLT telescope in Chile, Voyager, Galileo, and Juno have participated in an international mission to study the weather on Jupiter. The interim results of the work clearly point to changes in the planet's weather. The key point is that they are sudden and cyclical. In general, it has been no secret that the cold regions of Jupiter wear a lighter hue, and the browner it is, the hotter it is. Except that the twist is that for some reason the atmosphere of a gas giant, while raising temperatures in certain latitudes of the northern hemisphere, lowers temperatures in mirror latitudes of the southern hemisphere. And, unlike the Earth, these latitudes are separated by much greater distances. And yet the process is almost instantaneous, which is strange for a planet without changing seasons. But all this is a flower. The real berries are on the moons of the gas giant. They are famous because they individually symbolize all aspects of Earth's history and its transformation into a living planet. In February 2023, the Minor Planetary Center boasted the discovery of the gas giant's 12 new moons, leaving Jupiter surrounded by an entourage of about 95 satellites. The 4 largest of these, Io, Europa, Ganymede, and Callisto, were discovered as far back as Galileo in 1610. NASA has sent the automatic station Juno to Jupiter. Since 2016, it has been studying the composition of the atmosphere, measuring the strength of the magnetic field, and looking under the planet's cloud cover. And in 2022, a new space probe, JUICE, traveled to Jupiter to study its satellites. It is expected to reach the Jupiter system in July 2031. Let's wait, there's only a little bit left. Perhaps it is these missions that will lift the veil on the greatest mysteries of the solar system. There are hundreds of active volcanoes raging on the surface of Io. This satellite is the most geologically active object in the solar system. There may be a giant ocean lurking beneath Europa's icy crust. It is believed that in its depths beneath the ice crust there may be conditions favorable for life. NASA is set to send the Europa Clipper radiation-resistant spacecraft in October 2024. Ganymede, on the other hand, hides an entire inner sea of liquid water beneath the ice. By volume, it exceeds all of Earth's oceans combined, but it is stored mostly under the surface at a depth of 160 kilometers, about 99 miles. It started with the Hubble telescope, which in 2021 detected traces of water vapor in Ganymede's atmosphere. But it ended with the clear confirmation of a full-fledged magnetic field. Not just any field, but an induced dipole field virtually the same as the Earth's. Moreover, Ganymede is basically the only satellite with its own magnetic field shielding it from solar radiation, unlike Jupiter's more powerful magnetic field. The ancient surface of Callisto bears the marks of powerful asteroid impacts. It makes you want to put the 3 satellites together to get a healthy planet with volcanic activity and water, and then leave it to cool down for 1 billion years and turn into a second Earth. Perhaps the satellites of Jupiter will be the worlds where mankind will find the long-awaited signs of extraterrestrial life. Who knows what secrets Europa and Ganymede hold under their icy shells? Every year we learn more and more about the gas giant, but the big news is ahead of us. See you later, friends.